All right, good afternoon, students, ladies and gentlemen. Welcome to my sessions. Thanks for your time to come to my sessions. What I'm going to do today is I'm going to share some of my work or some of my ideas about engineering design for our future world. So before I start, let me introduce myself. That's me. I'm a professor in chemical engineering. I'm associate head of school for engineering and physical sciences in Malaysia campus, Heriot-Watt, Malaysia. I was listed as top 2% scientists in the world in the respective field recently. I received recognitions as a top research scientist in the country, TRSM Malaysia, Young Outstanding Malaysia Awards, Young Engineer Awards, and other awards. So that's me. And prior to this, I was a professor and founding directors in the palm oil industry, palm oil sustainable research. That's all my research area. I work a lot on the sustainable value chain on palm oil industry, mainly how do we optimize and maximize the profitability, sustainability of the entire industry. Why palm oil is because Malaysia is one of the largest producer, second largest producer in the palm oil in the worldwide. That's why I'm focusing a lot of that. But what as a chemical engineer I do is really look at the processing side, optimization, the utilization of the waste, energy recovery, resource conservation, and so on and so forth. I also working on a lot of biomass processing, integrated biorefinery, other than palm oil industry. I also work on sago industry, plastic waste, and so on and so forth. It's really looking at how can we recover the waste and make it as a more profitable, sustainable, in terms of also supporting the SDG, I think Sustainable Global Development Goal that proposed by UN SDG. So this is the things that I'm working on. Okay. So what I'm going to do today is really share with you on envisions what engineers can do in the future, and give you some ideas about should we still need engineer in the next couple of 10 years, 20 years. So go back a bit of rewind on where we are today. Okay. So this is the Gantt chart of the Malaysias Transformation over the years. Since the formation of Malaysia in 1957, that's called Malaya at that time, then later we become Malaysia, and so on and so forth. When we first started, the whole country is mainly based on agriculture-based economy. Then in the early 80s, we moved into manufacturing base. This is quite common. I think when you learn history, you know about this, right? So we start with agriculture, we plant a lot of palm oil, we plant a lot of rubber. I think that's the largest that time. Then later, a lot of them become manufacturing. So we, instead of selling the raw rubber, we move into latex and so on and so forth. That's more on the manufacturing. Then later on, when it comes to early millennium, then the country has moved from industrialization into a servicing industry. So you look at how Singapore was performed, so there are a lot of service industry. So country also moving into that direction, more on the innovative-led economy. So new ideas, new inventions. That's why a lot of new techno entrepreneurships coming up and so on and so forth. That is that year or millennium kind of years. Until today, we are still very much on this space on innovations economies. Okay, that's why you can see a lot of the Grabs coming in. We have the new technology company coming in, and so on and so forth, then leading the world at the current junctions. But what is the future? This is something into the age of humanizations. I think this is where the AI coming in, people feel that we are disconnected from humans. And people want to have the human touch. And that is where the new economy to be in the future. Okay? And the key success is using innovation and knowledge to gears towards how can we make our lifestyle better. If you watch a lot of movies, I like to watch movies, and that's where our futuristic ideas coming in. So you look at Iron Man as the typical movies that I like to, because a lot of people watch it. And then that's where a lot of people envisions our future to be. We have Jawas talking to us. That's the real. It may happen one day. Nowadays, you can see your phones, you can say, I speak to my mom. Ding, you call. It's AI. This is coming into our life. So Javas maybe happen in one day, they become a reality. So that is where the innovation coming on, why we need people and so on and so forth, right? And then you can see one of the challenges that you notice over the economic structure is increasing the technology complexity. More and more complexity of the technology, more and more innovation has to take place to ensure this can deliver to what we have today. Those days when we are young, if you have any grandparents or parents here, then we are talking about phone. How's your phone look like those days? Even we talk about mobile phone, it was something like a very big shape, 1980s, then you have to climb above the truck to answer the call because the network is not so good. But why today you're just sitting in anywhere of the place, you can see answering a call because of technical communication. And who are those people who are doing? Engineers, who invented this, informed this, and changed this world. Okay. Again, I do some reality check. What have we achieved since independence until today, 63 years ago, where we are? So we have achieved a lot. We have increased our innovation index in the country. We have market exporter, 26 ranked. We have competitiveness as 27 out of 63. We have the knowledge over a lot of research publications rank, and then as also index on 22 out of 63 countries. Not too bad, but what we have under the now. So, we have a lot of innovations, but still we have a lot of patents that are not patented. A lot of technology has not been adopted. Okay, and then we have so many things. Application per capita is still low. Our startup procedure is so difficult, not happening in the country, and so on and so forth. Those are a resistance for us to really become an innovation country or moving into the human-led economy. Okay, that is what we are today. In order for us to address those challenges, we need to really look at what are the country moving forwards. Okay, this is a study that I have conducted years ago by EPU in 2016. They look at different economic sectors in the country. So what I'm trying to share with you is really look at bigger pictures. Do we need engineers? Where is engineers placing? Look at this chart. What are the sectors that is going to be really push ourselves into a space settler and over the percentage of innovations? So the higher the value, the better. So we are looking at the top. Automotive, chemical processes, pharmaceutical, electrical, telco, and so on and so forth. Food processing. This is really going to be the future. And that's one we want to push it higher. And you look at those terminology, you can start reflecting and relating yourself. Being an engineer, are you required there? The answer is yes. Okay. But later I will explain to you what engineers do. Okay. And in about 3 years ago, one of the projects by Academy Science Malaysia, they have identified 95 emerging technology that are going to change the Malaysia context, how the transformation of the country will be. And I know this is difficult to read. If you're interested to read this graph, you can actually go to Academy Science Malaysia, download the report, and you can see the graph in detail, which technology that is identified. But in general, they're divided into 5 categories. One is the neuronological, nanotechnology, green technology, digital technology, and the last one is, what's this? Yeah, oil technologies. So this is the future of the technology they have identified. Okay, and this is where we contribute to we call it envision ourselves by 2050. What we require and what is the new development that required for us to venture into in the futures. Okay. And out of the 95 technology, they've even brainstormed further to look at the 21 most impactful technology. This is something that I want to highlight here. So in order for you to look at, we have the safeguard of the wellness. This is something that we do. And then later with the demoralization of the knowledge. And finally, we also have to look at the value added. Out of these sections, we look at the area like ocean thermal technology, conservations, fuel cell, the solar power. We have looked at the integrated periphery, where my research area is. And then wastewater nutrient recovery. This is all the needed technology to be invented, to be needed for the country to move on. And then you can look at virtual reality, cloud computing, 3D, 4D printing, data, big data, and so on and so on. Those are all the big names here for you. When you hear this, who are the most people who are involved in this? Because this is where the future is. Along to my talk, engineer, design the world. Where is this world going to? And this is something that they have portrayed for us to think about in 2050, where we are. I think we have done that similar approach when we have Envision 2020, although it only achieved about 70%, 80% of what we envisioned when I was young. This is something, the future that we want to look into when come to 2050. We have flying cars, probably, because watching the movies, we think that by 2050 we may have flying cars. We have the high-speed train, we have all the space traveler. This is the the SpaceX is coming in, right? It's not that we think of, we can, but something is quite common. It's something happening now, okay? And then we're also talking about smart dust sensors because of the haze and things like that. People will start inventing into all these areas. Hypersonic airplane, no, this is very high-speed airplane that you can travel in talking about more than 1,000 kilometers an hour kind of speeds. And then AI control, CCTV, props, holograms. I think holograms entertainment is already exists. It's just not common. With the 5G in place in the country, we have holograms. This is something in the pictures. So this is not really a dream, but it's really coming in. It's just a matter of where we fit ourselves into. Okay? As an engineer, where we are. And super smartphone, where we are talking about, everyone has a smartphone, but this is a more flexible, thin, something I have seen people actually hybrid in your skin. You don't need to carry a phone anymore. It's part of your skin. You can just touch it and then it can come out. And those are intelligence, robots, energy, flooding. So all this will be in the 2050 for the country. Okay? Right. So in order for us to materialize whatever dream that I'm mentioning just now, the country has came up with a national science, technology, innovations policy. I just happened to be part of this project. So I was invited as part of the Young Academy Science Malaysia under the Young Scientist Network to contribute on these areas. That's why I know all this, because I was one of the contributor in development of the projects, looking at crafting the master plan for the development of this. How do we achieve that? It's honor for us to dream big, but then how can we bring the nation to that? Okay? And with all this formulation of all the works that we identify the national priorities area, the latest development that we look at into the SDG, we call it MISTIE, Malaysia Science, Technology, Innovation and Economy. So we have to tie our science and technology into economic sectors. And that's where we change our world. That's where we transform our world and transform what we used to live today into 2050. And that's where we dream will come true. Okay? And that is what the national is planning. And as an engineer, we can contribute into it and look at it. What are the sectors that we look into? This is where SIE is really a way to bring prosperity into reality and the society well-being, global competitiveness. Look at what I did a reality check just now. Bring us to the future. Okay, having looked at this is what the sectors is. This is the 10 economic sectors on the top, which is energy, business services, culture, tourism, healthcare. We also have the water and food, agriculture, education, and as well as the environmental and biodiversity. What are the technology that you look at into the required in the future to bring us to where we are that we look at? 5G, 6G technology, sensors technology, 4D, 5D printing, advanced material, advanced intellectual system, cybernetic security, AI, blockchain, neutron, and biosensors. All this thing is to hit. When you hear about all this terminology, you can hear something. It's technology grievance. Okay? And who are the inventors for all this technology? So that's the question mark. That if you found the inventor, that's where the future is. And that's the future of the world needs. Okay. And this is the national niche area of the economic sectors, like I mentioned just now. So they'll look at those technology that we want to, sectors that we require, right? Renewable energy, I think this is quite normal. Everyone is talking about sustainability. We want to have renewable source of energy. We want an energy storage system. Why? Because you want to have fuel cell car, you want to have battery cars, you want enhancing your battery storage. You want to look at microgrid, for the population who are outskirts from there, have no access to the national grid. Where they are, they want to talk about microgrid. They can power generation, supply the electricity, 100% of us getting electricity 24/7. Okay, we are very fortunate because we are located in the peninsula where we can actually 24/7. Our downtime is very, very minimal. But if you go to East Malaysia, Sabah, Sarawak, they have a lot of challenges to actually electrify the people there. So these are the future area that we're looking into. Precision medicines. Want to prescribe a medicine for you to eat, where you just, for example, nowadays a lot of the healthcare product, you need to eat 10 tablets a day. But can we actually make it one tablet suitable for yourself? Positionally, exactly the dosage according to the needs of your individual. We can have a 3D printers print the medicine in future. This is a futuristic thinking that we want to look at. Premium food, super food. I mean, all this is really talking about the future technology and area that we want to look into. Okay. And also, we also look at innovation of eco-product, convert from the waste. How do we recover the waste? Because we have so many issues. I think everyone hear about these plastic issues. We have the single-use plastic go into the sea and then the turtle die. All these things. It's really a solution. How do we create a circular economic model with recovering the waste into our products? And then this is the national niche area of the economic booster, something that we want to boost the economic return. COVID-19 have caused the economic downturn. We have a drop in the GDP. I think of us here all this big terminology. So how do we recover from those? This is the area that we want to look into. So we look at the computing facility, promoting local context, supply chain on the waste management, forest management, digital healthcare. All these are really coming into pictures. So we need to be part of this so that we will be relevant in future. And that's where the innovators coming in. That's where the people are going to get job and the needs of the society. For us to be part of this future, ensuring that we are aligned with self with this. And the next question is, do we still get jobs as engineers or future jobs? What is the future job look like? According to a study that 75% of the jobs in future will be somehow related to science. Okay? You need to be science, technology, engineering, and maths, STEM related kind of work, 75% of them. However, the challenge that I face, or we face now, for a 15-year-old boy or girls, probably those who are sitting in front of me, or a few years ago, none of the 42% said they are not too good in maths. 35% said they are not good in science. 35% said they are not good in technology. So excluded this cohort of the students or this group of the community, we have left with very few talented, good students who can pursue in STEM educations. But like I see just now, if you hear from my talk just now, you notice all the future is about technology. All the future is about innovation in changing the lifestyle of the humans, of what we are living today. We require a lot of innovators. We require a lot of people who are good in STEMs. Therefore, if you are any one of you still studying in STEM, there is a very great career for you to venture into it and make sure you stay on it, stay put and go through that, and you will be needed in the futures. I also collected some information because this is an engineer's ring talks that I want to focus on. Out of the 58 occupations, critical, we call it critical occupation, means something that very required, needed urgently today and the next coming of 5-10 years. Though out of the 58 of them, you can see this is the listed engineers. Okay, we have industrial productions engineers. That is normally, who are there? Chemical engineers. Okay, if you study as a chemical engineering, you most likely are going to serve as a industrial and production engineers. We have civil engineers, we have mechanical engineers, we have electrical engineers, we have electronic engineers, and we have telecommunication engineers. So all the engineering discipline, most likely, that offered here that you will study will be needed. Because look at the big pictures just now. You notice that without I'm telling you further, you already notice engineer is needed. Because that's where we change. We need the people to be working on that space so that we will be still relevant and supporting the national development. For those who are in my room, in most likely 5 years down the road, you'll be graduates. Let's say you join engineers, you're going to be needed. Because look at what chart that I've shown you just now, until 2050s. We still need a lot of innovation and still need a lot of development. It's not something that happened today, but it's still a lot of development. So engineer is still needed. Okay, go back to be a bit rewind. So for those who are not sure, what engineers, when Denny has talked about so many engineers, chemical engineers, who are those people? What are they doing? Okay, so I'll give you a bit of background about engineers now. Who are engineers? I have shown 4 pictures. There are 4 of them. Can any of you tell me, are they engineers or they are non-engineers? Yes, please. Just give it a try. Are they all engineers? No. Who do you think they are not engineers? This one? They are not engineers. So you don't think he's engineers, okay? How about the other 3? Engineers. Okay, how about you? All are engineers. But the answer can be anything, don't worry. All engineers, okay? So the boy said all engineers. The answer is, they are all engineers. Okay? Now, the next question I want to ask. Can you spot the similarity? Not spot the difference, huh? We are spotting the similarity of the pictures. Come again? Okay, they are civil engineers. So they are engineers, doesn't matter. Tell me what is the similarity that they have. They have? Construction. These 2 are not constructions. They are all analyzing something. Very good. They are looking at something. What else? Similarity. What else? Something very obvious. Just look at the pictures, something obvious. What is the similarity that you have? Huh? What they wear. Very good. I like the answer. What they wear. So, what they wear? The helmets. Very good. Engineer always wear helmets. Because when you go to the factory, you go to the place, that is where you need to protect yourself. And that's what we call it personal protective equipment, the hats. What else? What, the hats and the attire suit. So this is also part of the requirement for the engineers to wear the suits when you go to a certain place. Again, it's a PPE. And last things, very obvious. All the 4 pictures, they have one similarity. Very, very obvious. The boys? What is the similarity in the pictures? No. Construction is the only 2 of them. Come. Give it a try. They're looking at plans. Okay. One of them looking at the equipment. Not really. Some more. Come. Faster. Keep going. They are planning something. Okay, don't think beyond the picture. So just look at the picture. Just look at the picture. Working in fake factory. Okay, come. What is the gender? They are boys, they are guys, they are men, okay? Is that the reality that the answer is most of the engineers are male? Engineering is a male-dominant industry. Fortunate or unfortunate, that is the reality. Okay? However, there are still a lot of female engineers in the world. Okay, there are a lot of good female engineers. So for the females who are watching my videos or those who are listening to me, don't feel disappointed. Engineering is not only for men, it's also for females. Therefore, I just show a picture here. There are a lot of female engineers in the world, and there are a lot of female engineers, successful female engineers who graduated from Heriot-Watt and then now working in a very good industries. And they are doing very well in their own respective area. So for those female, don't get disappointed. You are still needed in the industry. I always tell these stories why I said female is still needed in the engineering firm or engineering industry. Although female and male, they always complement each other. Okay, they always complement each other. Engineers, men, they have a bit of bigger visions. They always take things very big pictures. They look at things very big pictures. While the female are good at the small calculations, the detail checking, crossing, they are just supporting each other. So you need, in order for you to have a healthy environment, a healthy engineering firm, you need both gender. Cannot be only male dominant while female is not needed. It's not. It's just need both because both brain work slightly differently. So that's why they are good at certain different things. We need to utilize them for the benefit of the company. So for female, you are still required and encouraged to do engineering at all. And for Heriot-Watt University, we do offer a scholarship called Women in Science and Engineering. If you are interested on that, go and talk to our staff to find out more. It's a project that I championed. I started off to really promote female students who pursue in engineering or in science education in general so that you can pursue in your career. And that project is really trying to mentor and providing the necessary support to grow female leaders in the futures. Okay, so that's why engineers is not only limited to men, but also on females. So next is, what is engineer? Engineer is actually defined as a person who solves the humanity needs. Go back to what we have listened this morning or this afternoon just now, that we talk about future technology, invention that we are looking at too. And those are the needed of the human for the future. And who are those people who are going to bring this technology into reality? It's engineers. We are the person who are going to bring the vision, ideas into reality. Okay? We use technology, we use maths, we use physics, we use all the knowledge that you gain over the years when you are young into solving the issues related to health, environment, sustainability of the resources, energy usage, and safety of the workers. Why we say safety is important? Because in order for you to protect the people that you're working in the plant, engineer is bear the responsibility to design the place to be safe. How can you design the place to be safe? Because you are engineer, you have the knowledge to know the conditions that you operate in the plant, pressure, temperature, phase, and so on and so forth. As a chemical engineer, you need to know all this, and therefore you can design the system ensuring it will be safe for the people who work in the plant. Okay, so as an engineer, you need to ensure that. And what you really do is using mathematics and science, particularly physics, because that is one of the most important course that you need to do so that you will be acquired knowledge. You can design the project, you can design the plant, you can design the equipment to be sustainable, to be effective, high energy efficient, safe for people to use. Okay? And where we are working, we can start from the research. We do a lot of research. We look at new technology development. We can look at new programming. I work in computational research, so I use a lot of programming. I use a lot of mathematical equation to represent the behavior. And then I can optimize the system using a mathematical modeling approach. That's why research is. And then we can also discovery or development, which is really working at the productions, convert your new ideas into reality, produce a prototype for yourself to convert the raw materials into products. And we look at design. And this is something that I enjoy the most, I like the most, because we're talking about develop something that has not been appeared in the world. How can the 2050 visions coming out without knowing this is something that we have? Because we have the ability to be creative, we have the ability to think what we want in the future or what we need in the futures. For example, when iPhone have started years ago, no one actually thought the phone can be without a button. Okay, if you read the story about iPhone, they are the one who started out as touch screens. Nobody cared. I mean, those days, if you ask your parents, they were not about, imagine, actually we have a phone without a button. All of them, they're with a button. If you look at the Nokia, and why Nokia is face off, because that doesn't change from a button phone to an unbuttoned phone. And the entire community or the lifestyle of the people have changed from a button phone to an unbuttoned phone. That's all. And that's where engineers come a role and play a role. So we design stuff, we transform stuff that we have not been happen. But you must be able to articulate and present your idea to the people, to your customer, to your stakeholder. That's something I'm going to build. Okay, any engineer, including civil engineer, for example, Twin Tower, Malaysia Twin Tower, before it was built, how do you know the Twin Tower look like this? It's the engineer who go and draw the drawing, architect together with engineers, and then they build those things that have not been seen. No one has seen a Twin Tower before when it was built, right? That's the truth. That's what engineer to be. Okay? And we're also working on processing, productions, testing. So, for example, we actually produce a lot of products. As a chemical engineer or process engineers, we look at any production. So we have to ensure the production is actually effective, produce what we want today. Okay? Any product that you have, you need productions, large-scale productions. And that's where engineers come in to ensure the production is safe, the production is effective, and produce the product that we would require. Okay. And then also some of the engineers work on the sales because they have the engineering knowledge. They go into sales, or not really sales any product, but they look at the specific product. For example, valve. If you know valve, the big valve that you have in the industry, the valve that you can open and close, they have a very technical engineering background about it. What kind of valve? They have ball valve, needle valve, butterfly valve, gate valve, and so on. Each of them have a different purpose. Each of them have a different performance in accuracy. So it go back to yourself. What is the pressure drop that you want in the process? What is the ability, accuracy, motor, so on and so forth. So they have so many types of. So as an engineer, you are able to explain those. And then we also work at operations. Like I said just now, we are maintaining the equipment. We are maintaining the facilities. As an engineer, you are required to you learn about how to service the equipment, ensuring it will be delivered on the product that you want. Okay, and construction, this is more on the civil engineering, mainly building stuff. And then management, some of them, they move upwards into a CEO. Just for your information, Heriot-Watt CEO is actually engineers. Professor Mustar is an engineer. Our deputy provost is also engineers. He's a electrical engineering, electronics engineers. So some of them, they're actually moving upwards later. And a lot of the company nowadays like to hire engineers being their management person. Why? Because engineers able to change, getting a big or complex issue that we are facing into smaller pieces, solve them, and then integrate them into one puzzle. That's the ability of the engineers. That's how we can solve so many equations, so complicated, but we still get the solutions. That's where we are, and that's what we do. And finally, education. This is what I am. I'm actually enjoying being an academic. I enjoy sharing my knowledge, and I choose to be an educator. And that's why I'm here today to share my knowledge with all of you. Okay. And this is some of the diagram that I want to show you is about the drawing of engineering drawing, how they look like. This is something that you're going to learn and something to do. This is a chemical engineering. This is one of the projects that I personally involved, designing a biogas power plant, converting raw material of the wastewater into biogas and generate power. So this is how we do that. So you have to see all those drawing, what is it? Every single line of them meaning something is a pipes. And then what is the size? So you need to label. Why you need to learn all this? Because engineers work with different engineers as well. We work with electrical engineers, we work with mechanical engineers, we work with civil engineers. We have to present this in a clear manner so that the person who's going to build this for you will according to the pipeline. So that's where I draw my raw material, and then I'll send it to the storage tank, and then I have a pump here to pump it to my first segment, which is my anaerobic digester, to extract the gas, and then I have a treatment of the aerobic section, and so on and so forth. That is how you draw, and it's going to be built exactly like this. Okay? For a mechanical engineer, so we instead of the big drawing that you have seen just now, we are talking about very big equipment, big plant. Mechanical engineer work on machine. For example, if I want to take one of my pump here, can I draw it how it will look like? Yes, go to mechanical engineering. Then they will draw the diagram about the pumps. But this is just an arm that they have designed. This is actually done by my students. This is a student work that we have in Heriot-Watt. So they actually have to do a design, how the movement of angles, they have to calculate all the strength and then able to move according to the angles that they want to look into. And this is a fundamental or some part of the robotic arm design. So you're going to learn about all this movement so that you will be able to operate. And as a mechanical engineering, you won't be able to build a robotic arm because you don't know the programming. The programming will come from the electrical part. So you work with electrical people, they will come with the programming and do the control systems. But the mechanical part will actually design the grab power, the movement, everything. That is more on the mechanical. So we, as an engineer, we work as a team. We never work alone. We work as a team. You look at what I did in my process. I work with the mechanical engineering to build the pipe. I work with the electrical to build the control systems. Okay, and then this is the electrical people drawing. This is just one of those. Again, it's my student project. They actually draw the gate, how they control the systems. Open, close, power go here, there, and so on and so forth. This is electrical systems. Okay, and then next thing is where we work. All right, a lot of questions asked. Oh, okay, you have done all this. You see, where are we? Am I only chemical in oil and gas? Am I only mechanical in machine? Am I electrical only working in Intel? The answer is no. As an engineer, you work everywhere. It depends on where you want to be in future. If you want to be in oil and gas industry, go ahead. As an engineer, chemical engineer, I can work as a process engineer in oil and gas industry. I can also work in a wastewater treatment company. I have a lot of friends or students working in a wastewater company. I have also a lot of my chemical engineering students working in Intel. Why? Chemical engineer working in Intel. Why? Because we work as a process engineer. We can, knowing the process, we can optimize the process, we can make the process efficient. That's why chemical engineers do. Mechanical engineer, also same. Am I only required to design the machine? No, the answer is not. You can work everywhere you want. You can go into the oil and gas industry to look at the pumps, compressors. You can work in the automotive industry. What am I doing in automotive? You can design the material for the new motor automotive. You can simulate the air performance friction between the car and the air with the speeds and so on and so forth. You can have a crash analysis on the car. So all this can be involved. So engineers involved in every spectrum. So then the next question, do I get job? The answer is you get plenty of job, depends on where you want to work. Okay, and that's why you can look at what I presented. The needs of the engineer in all the sectors are very, very critical. Why? Because there are plenty of areas that you can work in. Environment, power generation, electricity. We need engineers. Why? Because in the operating plant, you want to ensure the plant is efficient. You need chemical engineering, you need mechanical engineering, you need electrical engineers to control the system. Everything. Okay? And just giving about, I have mentioned quite a lot already, chemical, mechanical, electrical. Why I have mentioned, highlighted these 3 or 4 is because it's the mainstream of the engineering in the country. So there are 4 main streams. Just remember, chemical, mechanical, civil, and electrical. This is the 4 mainstream in engineering. This is the largest umbrella for all engineering disciplines. Okay? Under the chemical, we have biochemical, we have gas processing, we have bioprocess, we have polymer, and so on and so forth. There are more to come. Under the civil, we have architect, we have building, services, structure engineer, and so on and so forth. Under the electrical, we have computer, electronic, and systems. We have the mechanical, we have aeronautical, automotive industry, and so on and so forth. And finally, we also have hybrid, for example, like mechatronics. It's a hybrid between mechanical and electricals or electronics. Petroleum is really hybrid between chemicals and geologies. Environment is between civil and chemicals. So there is a hybrid of those. So what is the main differences between one another? if you want to stay in Malaysia, if you want to stay in working in environment and being a professional engineer in futures in Malaysia, the advice is always register to the mainstreams, which are the chemical, mechanical, electrical, civil. Why? Because if you have any submission document in the future, if you are the main 4 stream, you can sign off any subdisciplines, not vice versa. If you are electrical engineer, you can sign off any document related to electrical and electronics. But you are electronic engineers, you cannot do the electrical part, you only can do the electronic parts, right? So that is the strength of being a mainstream engineers in the future. And do register being a graduate. Once you graduated, make sure you register to the main streams. And you have to check whether the accreditations requirement of the particular course are registered to the main or the sub-discipline. Okay? And that's all for the different engineering discipline. And in Heriot-Watt, I just started to take a bit of ideas about for you to know where is Heriot-Watt. And we are located in Malaysia now. That's where our campus is. But other than Malaysia, we do have a Dubai campus and UK campus. And all the courses that we offer is identical. Chemical will be identical, all 3 courses. We actually teach in the course teams. Some of the courses that you are required to teach in a global teams. So they have to, for example, I teach in Malaysia, you teach in Dubai and UK. So 3 of us has to share the load and teach our students in a different times. In the same time zone, all of you might be, all my students will go to your UK time, UK lectures, or all my students go to the Dubai lectures. Depends on the courses. Some courses do that arrangement, some courses don't. Depends. And then the lab work you can do in Malaysia. So that is actually ability for you to expose to international educations while you can also access things to local facilities. And then also our expertise in different campuses have a slightly different. For example, like myself, I'm doing a palm oil. None of the UK or Dubai staff will actually know what is palm oil. So if you want to work on my area of research area, then you come to Malaysian campus. That's what it is. Okay, so what is the overview of course descriptor? So this is mechanical. We have the covering, as I mentioned already, you can do aerospace, oil and gas, food and transportation, anything. That's mechanical engineering. And then we also have the chemical. Chemical, you are really converting a raw material to a product. Process engineers. We look at sustainability. That's what I do. You see, I do optimization, I do modeling. That's what I do. So I do a lot of design. In chemical engineering program, we actually have design from the 1st year to the 4th year. And this is the only course in the country, or generally I would say, that have 1st year to final year design project. And because we are building according to the years, the students become very, very strong fundamentally. And they can do very good job in the design. Comments from a recent, one of the industrial panel that visited our presentation by our 2nd year student, my 2nd year students. He told me that, oh, is this a 2nd year student? I said, yes, it is my 2nd year student. Their thought is a final year project students. Because the quality, the ability of the student thinking about the projects start from the 2nd year and on. So they can very, very strong in design. They can do a very good design in the future. And that's how we train our students to be. Okay? And then for the electrical engineering, we also have a very strong discipline in electrical. And our program is accredited under electrical, like I mentioned, it's mainstream. So you can be registered as electrical. But we also focusing on robotics. We have some projects coming in the future that you can focus on robotic. If you are interested in robotic, you can also join electrical, and then you work on something related to robotic project in the future. Okay? And this is the course structure from mechanical engineering. See, really, you look at year 1, year 2, year 3. So they always have a lot of projects. Why we highlighted project here is we're allowing our students from the 1st year itself, they learn how to work with the teams. And then working on project, you're able to translate your knowledge that you learn, apply into a project. Okay, so that is why I always like project about, and then we want the project to be related to the industry. So we invited all the industry partners to give us project and work with the industry, maybe solving an actual situation, actual project they have in the industry. For example, like myself, I have coached students, my favorite project students, related to a industry project. He went for internship, he came back, he brought a project, we sit down together, we discuss, and then he did it for his final project. And now he finished the project already, he presented to the industry partners, you give feedbacks and so how to improve. And they want to apply the project into reality. That's the power of the project-based work that we are doing. We have a lot of mechanical engineering are also having the same. We have industrial-driven projects. So we work with a lot of industry partners. Depends on the area. Again, some of the lecturers work with a specific industry. They will do a project with them. Okay? And then you can see they have group project, individual project. That allow you to really working on projects. And like I said, project is the most strongest learning platform because you need to apply all your knowledge. And for chemical, like I said, I have very strong design element. And that's why I always proud of my program is from the first year you have design, second year you have design, third year you have design, fourth year you have design. But then each of them will have different complexity. And then with that training, after 4 years, I'm sure you are very, very strong in design and stand out and tell the world how you do your design. We tortured our students a lot to really come up with very novel designs, very new ideas. The latest project that I'm working on is a plastic recovery using chemical platforms. How do you transform the plastic? What are new products you're going to develop? So we are talking about new things, the inventions. And then at the fourth year, they have to come up with pitching sales to their clients to pitch for the money to build the plant. So it's a very interesting project that we have did. So we have chemical plastics recovery, and then we have given us option to build the plant in Malaysia or Dubai. Not Dubai, Edinburgh, Scotland. Because we have project students from the UK and project students in Malaysia. And because they are doing the same projects, they are given option to analyze the location, analyze the feasibility, analyze the market, analyze the feedstock, analyze the product. They designed it. It's very interesting projects. And then all the years you can see we have design project all the way. So I'm teaching year 2, year 3, year 4. So I'm sure by end of the year, you will be good in designs. That's something I guaranteed that my students are doing very well in designs. Okay. So for electrical engineering, we have also project, like I say, signal project, you see, and then you also have final project. So this is always project because Heriot put a lot of attention in the projects. Like I said, a project is the platform that you learn to work with people, the platform that you learn how to apply your knowledge. You gain all the knowledge from the previous courses, but you apply, integrate. That's why when it comes to my course, I always say it's the most difficult courses because you don't learn any knowledge from my course, but you apply your knowledge that you learn and make it logical. I always like to ask few questions. Why you do so? You need to justify. Justify your decision. Because as an engineer, you always need to ask yourself, why? With the answer, then only you know you are making a right decisions. Okay, that's why this is what engineers do. Okay, and then we have the project engineers, like you see electrical, we have different courses, allow you to choose project that you like. So for example, some students ask me, what electrical engineers do? So do they work on computer and things? Yes, you do. I have staff working on AI, artificial intelligence. I have staff working on eye tracking. How do we do deep learning? How do we do the crunching of the data back end to make sure we can do application in engineering applications? Okay. So what's so strong about our courses in Heriot-Watt? So we have global teaching team. Like I said just now, we work with 3. I work with UK counterpart. I work with different campuses, ensuring that we deliver the same course, same exam, same outcome. At the final of the year, when you graduate, you only get the differences is the name on the graduate certificates. There's no other difference in the quality. We mentioned that. All our accreditations is same. You know, we are one of the university that go across single accreditations across different campuses. If we fail, UK fail, Dubai fail. Or either of us fail, the entire accreditation will fall. That is the commitment the Heriot have given. So we are very, very strict on our quality, ensuring that we are delivering the same course. And then the way of things. That's how we got all the accreditations from the different professional bodies. We have the IEM, BEM, EAC accreditations. We have the IMACI accreditations. For chemical, we have iChemi accreditations. And for your information, iChemi accreditation, we are the first in the history Dubai, Malaysia, and UK getting it together as one single university. We submit a single document because we are confident on the quality that we have. We are confident on the project that we are delivering and the quality of the education that we provided. So we get that accreditation as a joint accreditation across different campuses. And then we also have IET accreditations for the EE. So this is coming, they are coming to visit us. Again, we are doing tri-campus submissions. We have passed the UK already. Dubai is going to be end of April. They are going to visit Malaysia in early of May. So we are going to be at a tri-campus accreditation soon, hopefully. Finger crossed. Everything will go smoothly. We'll get all accreditation at one go. We have already obtained ICAMI. This is coming into Malaysia soon. Okay, so this is all the commitment that Heriot-Watt has given. And then, as I mentioned, industry collaboration is very important for us to expose my students to the industrial project. We don't invent the view inside our university. You are prepared to work with industry. And that is all the name industry or industry selected university, or industry that we have worked with and project that we have engaged. So, and then a lot of our students are graduated exactly, and before they graduate, they already get jobs. Okay? Before COVID-19, most of our staff, our students already got jobs before graduations. During last year, a very interesting student, he obtained BP UK during MCO. He's now in UK. He's a fresh graduate, chemical engineers, graduated, and then now he's working in BP in UK. Because of he's a very active guy. He actually do a lot of additional effort to put in to engage with the company in the overseas. And then he now got a job in UK. And he flew off to UK during the first MCO last year. So that is how you can got into the good jobs. And all our student salary is very good. Not the one reported in the newspaper. Don't worry about that. Okay? Right. So, the quality of our staff, you look at our staffing is very strong. We have more than 80% of PhDs in ME, chemical, and EE. Most of our professors or lecturers or assistant professors are PhD holders. We also have professional qualifications. We have the awards, a lot of award winners. One of them is mine, so I have a lot of winners and awards from various professional bodies. And then most of my staff also are very good researchers, a lot of academician and teachings and so on and so forth. So they receive a lot of recognition internationally or locally. Okay, so highlight about Heriot-Watt University, we have something called positive educations. What is that about? So we focus on academic excellence, that's what you think about. We have a purpose, why you want to do things. And then we also have building the characteristics for yourself to work on the direction that you want to work for. And then also we think about well-being. Because well-being, a human is needed to be think about what you want to be. Your mental health is very important. That's why we're actually building all this. At the end, what we look at, you are creating impact across society impact, academic impact, environmental impact, and so on and so forth. This is all the objective of you being part of Heriot-Watt, because we bring you not only finding your academic excellence, but also finding your life journey, where you go and what things that you love to do. Okay, and that's what we call positive educations. And we have a program called Empower Program. This is something that we built upon our own development. So we have a watt, kilowatt, megawatt, gigawatt kind of a level. So we're allowing students to really portray your ability beyond your academic excellence. And then you will involve in different sectors, for example, people skill, critical skill, thinking skill, and so on and so on. This is something that we built upon and allowing you to be innovative, and you can participate in this program, then you can be rated, and then you'll be achieving your goals, and then you can present to your future employers that this is your own creativity. And we have students actually starting up their own business. I have students recently, chemical engineering students, and one chemical, one mechanical, start up their own business, converting food waste into biogas, and then they use it for cooking purpose. So they have donated one system in our cafe, and then working with school now. I think they are doing very good. This is something using your engineering knowledge, be innovative, create your own business. And we have Grow Global campus. As I said, we have 3 campuses. You can grow global anytime because we are identical in terms of course and structure. You can go anytime when you wish to after the pandemic. And we have different intakes on the different years. We have for the foundation, we have the April, July, and September. For the undergraduate, you always see me when September or January, depends on the courses that you are looking for. And the postgraduate student, we have September intakes. All right, I will give you about 5 minutes just to watch what our video is. And yeah, hope you enjoy the videos.
Year on year, day by day, we already have some sense of how the world is changing. We all know that science can amuse and fascinate us all, but it is the engineer that's changed the world. So, how do engineers make the world a better place? And how engineers can change the world?
Why does the world need engineering?
It's down to the engineer to look at every millimetre.
Literally going down to the atomic scale and building up.
From research and development to design and manufacture.
To constantly question,
how can we sustain the growing population of the world?
How can engineers provide assistance to the people that need it?
We need to be able to bring people together with a range of different skills.
We need to think outside the box.
we strive for the best, although we may not always achieve it.
You're looking at all these parts and you have no idea if it's going to come together.
We try.
Bring that together into one vision.
And you get the car and it fires. It makes it all worth it.
Engineering isn't just maths and sitting in front of a computer.
We can do things that have never been done before, and we're able to solve these gigantic issues.
Whether in energy production,
Combustion chemistry.
3D printed bones to cure worldwide diseases such as osteoporosis.
Nanotechnology.
Renewable energy sources.
or strengths of materials.
I want to be part of the engineering future.
To make everyone else's life better.
It's a great adventure to be part of.
That's engineering. That's our job.
All right, thank you. So that is give you a bit of background about engineers. I hope that I give you a bit of big pictures. And thanks for your time listening to my talk. I hope that you have enjoying much. Now I'd like to do a Q&A. Yes, they have questions, answers, but those are online questions. But if you have any question from the floor, you can have any questions. Nope. Then we just look at the questions from the online. Yeah. So what is the differences between mechanical and mechatronics? I think I highlighted past a bit on my talk just now. Mechanical is mainly on the main branch of mechanical engineering. They work on the machine, they work in strengths, materials. While mechatronic is a hybrid between mechanical and electronics. It's very specific discipline that you go into if you're interested. And that is only applicable maybe on do a bit of mechanical and electronics. However, if you being a mechatronic engineers or graduates, you can only register to a mechatronic discipline. You are not eligible to register as a mechanical engineers. And the disadvantage is when you do a signing approval of things like that, you can only specifically sign off document related to mechatronic. While if you have a mechanical engineers, you can do the bigger streams. On the other side, when you become a mechanical engineering undergraduate, the first degree, if you are really interested in mechatronic, my advice is you do an MSc later on. That will give you a more advanced knowledge while you have a fundamental, because the first degree is the one who deciding which discipline you registered to be as a graduate engineer in future, not your second degree or third degree. Right, thank you. Next. Whichever you like. Okay, there are so many engineering disciplines. Which one is the most after when I graduated? I think the question is really about what I have shared just now. What do you think you want to contribute to the changing the world? All the discipline is still needed, various aspects. Because like I said just now, if you look at what we have seen in the need from the study, from the national studies, we still need a lot of engineers, regardless of what discipline. Because our engineers very diversified, you can work in any discipline or any industry that you love to, is needed. Process engineering is still needed in all the manufacturing, oil and gas, food and beverage industry, water treatment, so on and so forth. Like myself, I do process, I do a lot of optimization, I do a lot of water treatment, biogas, everything is really up to your individual where you want to be and what you enjoy the most. Most important, look for the sectors that you like and you really enjoy and you have passion and purpose. You look at what positive education is talking about, it's really talking about purpose. Why you want to be an engineer? What is your purpose? Is your purpose is supporting the environment more, to make the environment more sustainable? Then you can choose a chemical or electrical or mechanical who really focus on that space. Meanwhile, if you really want to change the lifestyle of human, you want to provide gadgets for the people to support them, probably it's a mechanical or chemical or electrical that you can produce the support system for them. Being a chemical, you can also change the lifestyle of the people by providing the new products that you've developed. You know, chemical engineers also work on lotion development. I have one project with my students on looking at new lotion for the skin. Why? Because we are in the lotion or the chemical that we design is made higher permeability into the skins. So we're talking about permeability, and then you want a smooth lotion. You don't want to have a very rough. And smooth is talking about viscosity. So the new material. So we actually design new molecule, and that can be applied into all these aspects. You want to design a new pesticide which is not hazard to the environment, and so on and so forth. So there are a lot of work that you can do. Really, to me, engineer is needed, and we are changing the world. I think that as the keyword is we are really changing the world, but make sure we are changing to the world we are looking for. And like I mentioned just now, 2050, that's what we are looking for. Please work together, join Heriot or join engineering, and change the world together. Right? Thank you. So I think I'm good today. Thank you very much for your time. I'm really happy that you have here me, and if you have any further questions, feel free to contact me. You can easily find my email online. Just type Denny Ng, Heriot-Watt. You can Google me. I'm sure that is the first one you can find me.